Good morning, everyone. My name is Lucia, and today I'll be talking about something that sits between logic, language, and technologies, of which is ontologies. So ontologies are more of bringing meaning to the web. I'll try by all means to explain that in my presentation. So let's start with the basics. What is ontology? That is mostly the hardest question to answer, since in a way ontologies don't have a formal definition, but at some point it has come to a definition where an ontology is a formal, explicit, and explicit specification of a shared conceptualization. So to better explain that, it provides, in simple terms, an ontology is a way of representing knowledge. It provides a shared vocabulary and structure for a certain domain. You may think of it as a blueprint for understanding the concepts and relationship in a certain domain. So to make an example of that, whether in medicine, e-commerce, or even social networks. A more formal definition of it, as I've said before, it's an ontology is a formal, explicit specification of a shared conceptualization. But to break that down, when we talk about formal, we mean that it follows a structured and logical set of rules. For example, in medical ontologies, diseases, symptoms, and treatments are organized in a consistent and logical way. And then when you talk about explicit, it means that all concepts and relationships are clearly defined. Example, if you mention that a heart attack it's explicitly linked to related symptoms and procedures, by that we all know that you can never get a heart attack from eating a salad. So so doctors know that if you get a heart attack, then they know that there are some symptoms are linked to that. But we all know that you cannot get it from eating salads unless it's from your ex. Then that is possible. So with shared, we mean that it is designed for use by a group or a community. So doctors across hospitals may use the same technology, so that their systems and humans are on the same page. But that would mean that they know that if we are talking about a heart attack, sometimes it's mentioned as a different word. I've forgotten about it, but there's another word for a heart disease. So by that we mean that even though another hospital may use another definition for or another word for a disease, a certain disease, they are able to link it with the same disease in another hospital. So in essence, an ontology helps system and people speak the same language and interpret information the same. So when we speak about ontologies in the web semantic, we know that the internet is mostly designed for human read. But what if machines could also understand the meaning of the information, not just the data? The goal of semantic webs and ontologies is to make this possible. We define the term used in web context and relationship between them, allowing machines to process data and context. But how do we do that? Let's say you are on a website and the website says Apple is releasing a new iPhone. A machine without ontology might confuse Apple as the fruits with the word of the products or technology. So in this case, how ontologies help with that? They make sure that they link the concepts in terms of the Apple is not just the fruit itself, but is more of a product or a smartphone based on the ontologies that are available for it. So another example that you might see is that when you search for Nelson Mandela's wife, Google doesn't just search for those words. It uses ontologies in its knowledge graph to understand that Nelson Mandela is a human being and the wife relates to a spouse. So sometimes Google, even if you Google, it doesn't really show on his choreography that he has wives, but it shows that he has he had spouses. So that's how ontologies help link those words together. So ontologies aren't just academic theory like philosophical arguments. They get implemented and get being used everywhere. Search engine like Google uses knowledge graph, which is a built-in ontology to understand the concepts behind search queries. That goes back to the example that I was referring to, that if you're searching maybe for April, maybe April launch, it knows that it knows to relates that search with the April itself, but it knows that when you're talking about April and launch in some way that relates to technology part. So it's gonna give you results of the April company and related search to that. So with that, we move on to healthcare. So healthcare systems use ontologies like SNOMED to ensure that diagnosis recorded in one hospital can be understood and processed by another hospital. For example, when doctor writes myocardial infection, or that myocardial infection sometimes also is referred to as a heart attack. So with ontologies, system understand that they refer to the same concept. So also in cybersecurity, threats ontologies can help detect patterns such as linking certain IP addresses, behaviors, and file signatures to know to some known attacks. Another relatable example that I can use is think of Netflix. It uses the content ontologies to take movies shown with genres, themes, and moods, enabling smarter recommendations. So what makes an ontology? There are four main parts that makes an ontology. The first one being classes, sometimes referred to as concepts. So for example, in university, we know that the concepts that are present is more of student, courses, and professors, right? So with that, we move to the second parts of the second components of the ontology, of which is instances. Instances are just the real-world examples of classes. For example, Alice might be in a university. Alice might be a student, and CS 101 might be a course. So and then we have properties which define the relationship between concepts and attributes and instances. For example, a professor teaches a course. A student is enrolled to a course. Those are type of relationships that you might have in your ontology. And other restrictions and other things that you have is what we call restrictions. So these are rules that we have on your ontologies. So for example, a student cannot enroll in more than 5 courses. That might be rules or restrictions that you put on your ontology. And a course must have at least one instructor. So a person can't be both a student and professor at the same time. So these structures help systems understand not just what things are, but they help them connect. They help them know how they connect and interact, much like a map of knowledge. So why are ontologies powerful? So the first one is data interoperability. Imagine hospitals across the world are using different terms for the same conditions, same as the heart attack one. So ontologies provide a standard that lets systems share and understand each data. So they know that when another term is being used on another hospital, it's the same term that is being used in another one. So ontologies provide a standard that lets system understand and each data, and they also map them in both concepts. So another example is that another example is search and recommendations. Ontologies provide context. For example, when you're searching on YouTube, maybe for cooking tips, what happens is that if an ontology recognizes the relationship, what happens is that it can also suggest knife skills and meal preps as one of your searches. So with that, ontology recognize that relationship as being part of the cooking techniques. Another one is reasoning. Ontologies enable system to infer new facts, not just ones that are explicitly defined. So, example, if the ontology defines that a cat is a mammal and a mammal is an animal, without the ontology being explicitly told that a cat is also a cat is an animal, it can conclude for itself that a cat is an animal based on the facts that the first fact that we're given, that a cat is a mammal and a mammal is an animal. Another thing that we have is standardization. So that promotes reuse of knowledges across domains. So ontologies like Dublin Core are reused in libraries and universities and also in online archives. So let's do a comparison with other technologies. How do they differ from other different technologies? So, and the first example I'm going to use is relational databases. Relational databases store data in table, but they do not have semantic meaning behind that. For example, a table with a name, birth date, doesn't know that if a name is a person, place or products. And then we also have the JSON XML, which store data in structured data, which store data in structured data format, but it doesn't know the semantic meaning behind that. Machines don't all machine learning. The AI really do not know how the data links together, but they only just find patterns in the data. So, but ontologies can help guide and understand the patterns. Okay. So if you're interested in building your own technology, there are great tools available. So one of the most used tools is Protege, which is a free open source ontology editor with graphical UI. And another one we have is a W3C, which is a standard for defining and instantiating ontologies. Another one we have is RDF, which is a resource description framework, which has basic representation of information on the web. And then we have SparkQL, which is a query language for RDF data. Think it's more of an SQL for ontologies. So these tools make it easier to start modeling and structure knowledge without even deep AI or programming. So another free tools that we have, let's talk about Protege. Protege is one of the most used one. And another one that we have is linked open vocabulary, which is a catalog of all existing ontologies used in the real world. So with OntoB being a linked data server for biomedical ontologies. We also have Corsa and edX, which have courses on the semantic web and knowledge graph. And we also have W3C, which is an official specification for RDF, OWL, and Spark. So the future of ontologies is exciting as AI makes it more, as AI makes more decisions, we need to understand how and why does it make those decisions. Ontologies help provide the reasoning of trial. For instance, in healthcare, an AI recommendation treatment must explain its reasoning. Ontologies can guide and structure that explanation. First domain knowledge integration. Ontologies can connect data from agriculture, climate, and finance and healthcare, enabling global and holistic insights from all data. As AI and robots and the web evolve, ontologies will be the key of connecting and grounding intelligent systems in meaningful and interpretable knowledge. To wrap up, ontologies system go beyond data and meaning. They make the web smarter, AI more explainable, and data more powerful. As we build technologies tomorrow, ontologies will be the key in ensuring that we understand the world as they understand the world as we do. Thank you. That's all.